Hello guys, I'm back again. Another bypass test. This time I'm doing the oxygen sensor with my Picoscope. We've done a couple of VRS sensors on the ABS systems. Now I'm on trying to do a bypass test on a oxygen sensor. So what I have right now, this is my Chevy again. I unplugged a Bank 2 sensor 1, and I've got my signal wire back probe, and let's see here, we have a 500 millivolts is the bias voltage on my Bank 2 sensor 1. Pretty much tells us that the sensor is fine. I'm in the open loop right now, so my Bank 1 sensor 1, it's not working either, so it's stuck on 0 basically, but I got now, because of the fault, I'm in the open loop. But let's do the bypass test on the oxygen sensor and see if we can use this Picoscope. So as I said, I have my signal, I'm sorry guys, my sensor is unplugged, and I have my signal wire back probed. I'm all the way, I'm just going to show you right there. You can see my wire going up. Let's see if I can get, so right there you can see that I'm on my oxygen sensor. I have to keep my car running, my battery keeps dying on me, so okay, so now here's my spaghetti on the floor, and I'll try to explain what I'm doing here. So here's my yellow lead, okay, it's going to be my channel A. My yellow lead, just basically look at the voltage, and so down here I have, this is my cable. I just see the extension that this is connected to my signal wire on my O2 sensor, and I just have it on this negative side here, okay. So basically what we see here, this wire here is my signal wire from our O2 sensor, okay. So now yellow lead, I have this adapter here so that I can hook up both of my leads. I'm going to need a red lead for my generator, for my waveform generator, okay. So basically I have the yellow lead and red lead hooked up to my signal wire, okay. I hope this makes sense. I know it's a little confusing, but that's what I got on that side now. And the ground side from both of my leads, you can see the red lead and the yellow lead. The ground side is basically just hooked up to my ground lead, and it goes to my battery, okay. So that's pretty much it. So now, as I said, we have already our bias voltage of 500 millivolts. It tells us that the signal wire is fine. But in case that you have if you're stuck on 0, then you would have to check your integrity of your signal wire. So let's hook up the yellow lead first, and okay, and it's interesting that it seems like the Pico kind of drove some current. Now my bias voltage went down to 130 millivolts. Okay, and that's what we read on my blue channel now. And let's see if I can. See, it's 280 millivolts. Okay, so now we need to hook up our, I'm just going to turn it off for now actually. I'm going to turn off my generator. So let's hook up my red lead to my generator. Okay, that's good. And now it seems like after I hook up the generator as well, that my signal actually went all the way down to 0. Okay, so now let's turn on our signal, and let's go to we have a sound wave taking place. Let's just go to DC volts first. Just gonna go to DC voltage. So wait for a generator to change. There you go. So now we are at 500 millivolts. Now we can increase it and decrease it. This will go up to 2 volts. Of course, we don't need that much, you know, to test our oxygen sensors. So just gonna go up to let's see, let's go 900 millivolts. So everything is hooked up. So all the cables are hooked up there. We got a, you know, ready to go. And let's see what we got on our scan tool. And we see that our scan tool is reading a 750 millivolts. So there's some voltage drop across, but it definitely responds to my my voltage that I'm sending from my generator. And we can increase it a little bit more. Let's just go 2 volts, and it's pretty much pegged now on 1.1 volts. Okay, so let's so now we know that works fine. Okay, so let's see if we can do a I'm going to decrease it down to 1 volt. Actually, I'm going to go to 800. Let's do that. So let's go to AC Soundwave, and okay, and I already had it set up at 400 millihertz. Basically, this you got to go below 1 hertz. I'm at 700 millivolts here, and okay, let's see what we got here. How about that? I love it. So my O2 sensor is responding. It's changing. Let's change it all the way down. It's as slow as it can go. 100 millihertz is the slowest. Let's see how the scan tool responds to that. If it's gonna slow down or not. It should. There you go. We can see it's slowing down actually. Yep, it's working. And let's see if I can. Yeah, and also I set my offset here, so I'm above the 0 line. Okay, I got offset at 800 millivolts, so we are at above the 0 line. And yeah, I mean it's responding just fine. Works pretty good. Alright, so actually, to be honest with you guys, it took me a while to set everything up, and I was struggling a little bit. I'm going to increase my time base here on my so I'm going to go back. But anyway, it works fine. I'm just playing with my computer, but that's pretty much it. Now this is confirmed that this generator can be used to check the integrity of a oxygen sensor on a signal wire. I'm going to go back to 0 to see what that's going to give us. Actually. Okay guys, I had to play with this. It would take me too long to record all this, but anyway, it seems like this is the best setting I could do it so far. So I'm at 500 millivolts. Basically it's going to be a 1 volt, and I'm at the 700 millivolts of offset above the 0 line, and sound wave 6 hertz, and this is what we got on our oxygen sensor. So we can see the full amplitude of the signal. So this works pretty good. So most likely I'm going to save this setting and that should work for my testing. So I'm gonna change this to 1 Hertz, and let's do 1 Hertz, and I have to wait for the whole sweep to change, to go over until so the new speed comes up. There we go. So let's see what we got on the scan tool now. It's going to respond. It still seems like it's too fast. It's still switching at pretty much the same speed on the scan tool. So I have to go even slower than 1 Hertz. I think I was actually at the let's go 0.7 Hertz. And I mean, right now I'm just playing, so I'm trying to find the optimal signal for my sensor, and this is okay. I can go a little bit slower than this, and let's go 0.3 Hertz, and okay, I think this is fine here now. Like we can see the whole sweep. This will work, and most likely I'm gonna save this one for my I like this one. I really do. I think this is good signal now. Let's go maybe a little bit slower than 200. Let's see what. Well, but anyway, I think this is really good. I mean, I really like it. I mean, I'm just discovering more and more options, and on this Picoscope, on this Waveform Generator. Really cool stuff. Now we just, okay, there you go. Now it's even slower, but I change it to like 0.2 Hertz. So okay, I think that this is what I'm gonna save and use this for my O2 sensor signal while testing. So at 200.2 Hertz, 200 millihertz, half volt, 700 millivolt offset. It works pretty good. Okay. Alright guys, well this is pretty neat. I love it. I really enjoy doing all this researching and trying to figure out what else this thing can do. And more I do, I'm just having fun. I mean, this is pretty cool. So okay, so as I said, I'm trying to find a car that has the Hall effect sensor on the ABS to see how that's going to work, and then I'll try to find one with a VRS speed sensor for the VRS cam and crank sensor, and I'm going to customize my scanner, my Picoscope, my signal, so I can make a notch, and the computer can recognize it. So, well, that's going to be in the future. But anyway, so far so good. It's pretty good stuff, guys. Okay, appreciate you watching, and see you next time. Thank you. Bye. Okay, guys, bonus footage. I just cleared my codes, and now I'm in a closed loop. Here's my long-term fuel trim on bank 2. That's the sensor that I'm controlling with my Picoscope. So I'm at 25%. I'm actually kind of lean. So let's see if I change the frequency on it, is it going to change the fuel trim? Because it's let's see now. I'm trying to match the frequency from bank 1, but I mean it's in a full sweep. I'm not sure why he's doing the why he's so negative. I mean a positive. I mean it's in a lean. I'm not sure. Let's okay. So that's not doing anything. Well, let's try to go to DC volts and force this signal high and see if our fuel trim, if it's gonna go. Okay, so now I'm at 600 millivolts. Let's go up and see if it's gonna respond to that change in a signal. Okay. I'm just going up a little bit more. I'm at 1 volt right now. I'm just trying to see if we can use this to kind of, you know, trying to see why. Okay, it's changing in the short term a little bit. There you go. There you go. Come on, baby. You can do it. Cool. All right. Sweet. So now we should see the long term starts to response to short term. We should go. There you go. Nice. All right. Hey, I love it. Okay, so probably it's gonna go. It's gonna go now to yeah. Now we need to go down a little bit. Oh, this is pretty cool, guys. This is just crazy. How about that? I'm just gonna go to. I'm gonna drop my voltage down. Yeah, I mean this is really cool. So okay, now I dropped it down to 0. Now we should see that our fuel trim go positive. Now let's start adding fuel. So of course, you know, it's not gonna follow on my signal, but we can see now that you know, I mean, this is pretty cool actually. You know, we can test the computer as well. So I like it. Make it yeah, it goes. It will go to positive on the long term as well. Okay, it's working fine, guys. I mean, this is pretty cool. So let's go up again. How positive we are on the bank too. Car is chugging a little bit actually right now. We are peg positive now. I increased the okay, so I mean this is really good too. I mean we can now increase and decrease the signal on our oxygen sensor, and at the same time we can see that, you know, how the computer responds to changes in a O2 sensor signal. So I'm not sure why. I think it was positive, it was lean, even though, you know, I had a full sweep on my AC Soundwave. I'm not sure why I did that, but I guess it is what it is. But you know, if you induce just a straight DC volt, you know, we can test our PCM as well. Make sure that responds to our signal from the oxygen sensor. So now I should expect this to go. Let's see, still in a closed loop. So now you can see it's the short term is going down again, so I increased my voltage. So this is great. This really I like it. Okay, nice. Okay guys, another benefits from this thing. I'm sorry. I'm sorry. I'm just so excited about this. I mean, this is just something I never dreamed that could work like this. But now we can check our, you know, oxygen sensor, sensor signal wire to make sure that you know, we don't have issue there. Now we can test our PCM, make sure that it responds to, you know, reach or lean command signal on our oxygen sensor if it's going to change the fuel trim. Of course, it has to be in a closed loop, so and yeah, works fine. I mean, this is great. Okay, guys, thank you so much, and I'm gonna do some more stuff with this thing, so stay tuned. See you then. Bye.